So I guess the time has come. I don't think I see my co-chair, but I hope that Bobo is able to join us sometime soon. We have something of a full agenda. Does Richard want to say something? No, he doesn't. Yeah, it's a data tracker logging issue apparently. So the usual stuff that we see in meetings. Excellent. Do you want to say hi, Bobo?
Hello, can everybody hear me? Is the audio working fine?
Seems to be good.
Okay.
For once.
Well, I'm Bobo, co-chair here with Martin. Nice to see everybody, and thank you for joining us. Thanks, Martin.
Yeah, so there's the note. Well, I think everyone should be familiar with this one. We're being recorded this time, so don't say anything you wouldn't say to someone else. And this is our agenda today. We're not going to get a presentation from Dr. Alex, who didn't give me any slides when I asked for them, and doesn't seem to be online anyway, so that's fine. And I'll probably put EMAD's presentation together because I got one deck, and that means Ewan can take the first use cases slot, if that's okay with everyone. Anyone want to talk about the agenda? All right, so we thought since this is the first time we're meeting, we'd take a little bit of time to go through the charter. Bobo, do you want to take the helm when we go through the charter? I'll keep driving the slides, but you can talk through the charter for everyone.
Yeah, sure, that sounds great. So since, as Martin said, since this is our first meeting, we wanted to take some time to go over the charter for this working group, set some context, and of course, get any feedback from folks here that have any to share. So with that being said, the primary goal for Sframe is to respond to the growing need for end-to-end encryption for real-time conferencing sessions. We want to achieve this in a way that is separated from the transport layer. And we'll have exposed but authenticated media metadata that's useful for SFUs, also known as RTP switches. And so the goal here, and just a gentle reminder on meeting etiquette, if you want to talk, please press the raise hand button, and that will add you to a queue that Martin will manage. So the goal here is to define a secure encapsulation to provide authenticated encryption for real-time media content independent of the underlying transport. If you could go to the next slide, please, Martin. So this is obviously a very interesting space with a lot of interaction. So we thought it would be useful to review what we feel is in and out of scope in order to maintain focus. So for us in this working group, we've set out of scope signaling that's required to arrange Sframe encryption, especially considerations related to SIP. The motivation is that Sframe is intended to be applied as an additional layer on top of the base level of protection that SIP or STP provide, as well as other WebRTC changes, such as the payload format. The motivation here is that these WebRTC changes in particular will be addressed by a different working group, the AVT core working group, so they're out of scope for us. Go to the next slide, please, Martin. In scope for us are to define guidance for how Sframe interacts with RTP, especially with regards to packetization, depacketization, and recovery algorithms. And our motivation is to ensure it can be used in diverse environments such as WebRTC, as well as outlining the security properties that you could expect to see under use in common threat models. Next slide, please, Martin. Finally, we anticipate that several use cases of Sframe will involve its use in contexts where keys are derived from an MLS group key exchange protocol. So we consider in scope defining a mechanism for doing Sframe encryption using these keys, but obviously this does not preclude other sources of key material. Next slide, please, Martin. Some interesting sort of details about the encapsulation and what we hope to achieve. As we mentioned in the primary goal slide, we'd like this to be transport independent, so it can be applied at a higher level than individual RTP payloads. And what this lets us do is it means we could have, for example, application at multi-packet frames. So encrypting entire frames that span more than one packet lets us amortize framing and authentication tag overhead. Or you could choose to encrypt at a unit of intermediate size, for example, NALUs or OBUs, to allow partial frames to be usable. And these granularity levels are to be determined by the working group for what can be selected in the protocol. Next slide, please. In order to drive authenticated encryption, the encapsulation provides the following. Selection among multiple encryption keys in use during a real-time session, and an algorithm for forming a unique nonce within the scope of the key based on information in the encapsulation frame. Next slide, please, Martin. There's still things that the application that is making use of Sframe has to declare. For example, selecting whether Sframe is to be used for a given media flow, specifying which encryption algorithm should be used, provisioning keys and key identifiers to endpoints, and selecting the granularity at which Sframe encryption is applied if indeed multiple options end up being available. Next slide, please, Martin. I think that's it, actually, for the charter overview portion. So if there are any questions or comments, now would be a good time to raise hand and get in the queue to speak. Okay, I'll turn it back to Martin. Thank you.
Okay, so our next presenter is Ewan. Grab the mic and I'll grab the slides.
Hello, can you hear me?
It worked this time.
Yep.
You're a little faint.
Hey, Martin,
Yeah.
while you're setting that up, were there note takers set up for the session?
That's an amateur move on my part. No, there was not.
I can
Very
take some
good
notes.
pickup. Thanks, Richard.
I'm also seeing in the chat Bernardo Boba seems to be having trouble hearing things, so I don't know what's going on there, but perhaps we have a bug of some kind.
Yeah, that's my entire story for the last session, so don't know. Maybe it only affects people who know a little bit about WebRTC.
Okay, should I start or we're waiting for
Can you speak closer to the mic or something when having a little,
okay.
You're a bit faint.
I'll try to speak louder.
Yep.
Okay. So we started looking at implementing Sframe browsers, and we come to some, we had some thoughts and questions. So here they are. Next slide. So the first question was how to implement it in browsers. So they can be implemented in native because you can always implementing everything in native. There's also the Instable Streams API proposal, which is a new API to inject JavaScript between codecs and network so that you can do whatever transform after the encoder and before the network. So we started discussing that, and there are clearly some advantages to native implementations, like JavaScript does not need raw access to media content if it's native. If Sframe is implemented in native, you no longer need to have raw access to encryption material, which is a nice property as well. And in addition to that, browsers, if they're implementing that natively, can apply further protection. So they can keep control of which algorithms to use, which might be good in the future. Browsers can also implement the Sframe transform out of process, which would make it closer to something like EME, for instance. And also, there was this proposal called isolated streams, which is a way for the JavaScript to never get access to the raw media content. In which case, a native S transform can still be able to consume such protected streams, as well as produce the same streams. So based on those discussions at the last WebRTC meeting, the consensus was to define a native Sframe transform that integrates with WebRTC for audio and video. Next slide. So the idea would be that the native web Sframe transform could be used standalone in WebRTC. So basically, JavaScript would set up the peer connection. It would also gather the keys, generate the keys, and give the keys to the Sframe transform. And that is providing some good level of security, as well as some ease of use for web developers. In the future, it could also be used with a native key manager based on MLS, for instance. So in that case, the key manager would generate the encryption keys, and JavaScript would be responsible to do the setup of the pipeline and hand over the keys to the Sframe transform. I'm saying in the future because native key manager standardization could be done in parallel, but we can start sooner the Sframe transform standardization. So that does not preclude use outside of WebRTC, though. For instance, with data channel or WebSocket. I saw in the charter that Sframe is mostly targeted at SFUs. And that's another question I will have at the end of the presentation, which is whether we should scope it that way as well in the web, or whether we should anticipate that it might be used elsewhere. Next slide. So we started to work on implementing that, and very quickly there were obvious issues with implementing Sframe compatibly with SFUs or even existing browsers, especially when with video content. So when the Sframe transform is applied, the content is no longer valid video content, so everything is breaking basically. So there are a few alternatives. One alternative that is mentioned in the Sframe draft is to have a generic packetization, which seems nice. An alternative would be like to try to do a post transform, but that would be codec specific, so it's not really appealing, but anyway, it should be mentioned. So I'd like to mention that the generic packetization might be useful outside of Sframe, because the installable streams API is allowing to transform encoded content before going to the network. So installable streams is very generic and might also need to use in some cases, generic packetization. So that's something to keep in mind. So my understanding is based on the charter that was described, but it's not an activity that this working group should do, and that AVT Core should do it. So my first question to the working group is if anyone there is interested in, if anyone is working on it, or if anyone has started that effort already, because we would like to help there as well. I don't know if anyone can answer that.
Let's hear from Emad.
Yeah, so I'm definitely interested in helping with that. So what we have done in Google, we used some version of VB8 packetization in initial version, which seemed to be generic enough. But yeah, I'm definitely interested in helping like define a standard generic packetizing format.
Okay. Do you agree that it could be used by Sframe, but it could be used as well for?
Yeah. So yeah, instructable stream gives the possibility to do anything with the encoded frame. Right now, the use case we have is for it's encryption, but it could be other use cases to use the generic packetization, because once you have encoded frame, you can do whatever you want with it. So yeah, in the top of my mind, yes. But do you have a specific use case we can discuss? I don't have something specific other than encryption right now.
Okay.
And I think we're up to Colin Perkins.
Hi, can you hear me?
Yep.
Yes, good. So, I mean, obviously a generic packetization can be defined and probably fairly easily. It's probably something for the AVT core working group if it's for RTP, depends how this is being done. The reason we haven't defined this in the past is obviously that it has implications for the robustness, and if you just chop the packets arbitrarily, then you get less good performance in the case of loss. So I think it would have to be done carefully. So there are some implications that need to be thought about before doing that.
Thanks, Colin. Sergio. Just grab the mic, Sergio, if you...
Hello. Now, I thought that you were on the queue, you were automatically mute. Okay. That we have started working on an RTP agnostic video codec packetization format, and I don't agree that there is kind of problem with the robustness. I mean, it is not. I mean, it does not allow, for example, partial decodability yet, but it is not something that, for example, in WebRTC we are supporting. So probably it is important for some people, but at least for WebRTC, it does not seem to be the case. But anyway, we will. I have later on a full presentation on video formats and packetizers, so we can try to move the discussion for later.
Sounds good.
Sounds good. Tim.
Yeah, I don't know if this is going to get answered in what Sergio's just mentioned, but just to be clear, this generic packetization is on top of the existing packetization for the codec, or it replaces it?
It is replacing. I mean, in my case, it is replacing. I mean, it is useless to have to define, or if we are going to do something that it is agnostic to the codec, defining for every video codec is, I don't think is the best way to do. I mean, if we can have something that we work with all codecs and we don't have to make much work per codec, is better. I mean, if you have to define something and then you have to redefine it or how it does it apply to each of the different codecs, past and future, is like having a specific packetization for each one.
Yeah, I think there's a trade-off here between, as Colin pointed out, resiliency features and alignment with the codec. and the generality you're pointing out. I think the question for this group is how we navigate that and get the right level of flexibility while also getting these robustness properties. I would also wonder at what level we need to define that, like whether the Sframe framing could be defined at a reasonably generic level and then mapped to different packetization schemes as appropriate.
Okay, we have Justin.
I wanted to comment to that like I'm not sure there really is a tension here between resilience and you know the actual Sframe approach. It comes down to what we consider to be our independent unit, our frame per se, and you know, with H.264, you can have like a frame split into two different slices. With VP9, you can have it split into different tiles. Sframe could be applied either at the entire frame level or at the slice/tile level. So you could retain some of the resilience benefits you get from slicing or tiling, even when using Sframe, at a small trade-off of efficiency, because you have then multiple encryptions and multiple signatures. But I think we can retain the benefits of those types of approaches even when using Sframe.
Do you know what Google is using there currently? Is it the whole frame that is encrypted, or is it like finer-grained?
Well, we explicitly considered, supporting tiles when we designed Sframe. I don't know if that capability is actually used, in the implementation to date. Ahmad would probably know better right now, but we explicitly considered this, and like, I think it would just be an implementation detail.
Yeah, well, so we're leaving the full frame right now.
Okay. Magnus.
Yes, so as an individual here, I think what Colin is talking about robustness is that actually is about how to map, to a large degree, you're mapping it to what you consider in RTP as streams and SSRCs, etc. And that's where, because I don't expect most of you to do this really stupid trick, but I mean, if you leave it completely open, people are going to shovel multiple codecs into one structure and then send it over one RTP stream, and that, of course, has implications. So I think that's where I was pushing on the chartering stage to actually try to get this description, and especially with the scalable codecs, etc., and how you do handle those substreams, etc. I think that's where a large part of this discussion needs to be going. And that's one aspect of this. The other is, okay, what's the generic meta information that goes on the side combined with that? So you get the balance between how you structure media and keep track of its timelines and relative to each other, etc. Those aspects without exposing information and having reasonable sized encrypted units and all those things.
So I'm going to cut the conversation here, or the queue here, and then we'll let you get through the rest of this presentation. Sergio, you can speak if you think it's important, but we can cover some of these topics again.
No,
but you'll have to wait till Harold speaks first.
So just that the insertable streams API currently deals only with whole frames, but of course picking out part of a frame is just a matter of programming. So that shouldn't constrain anything about how this is done.
Okay, thanks everyone. Hopefully we have some notes on that one, and we can continue this one when we talk about this later. Johan, you want to continue the presentation?
Yeah, next slide. Oh, maybe you should skip it actually, because it's really like, okay. I have two additional questions related to Sframe. One is about authentication signatures. So as I understand it, the goal is to validate that received content is actually coming from a given user from the RTP stream. That sounds like a good idea, but when trying to think about implementing it browser, it appears quite difficult. It's really up to the application to decide what to do when signature verification fails, and there could be potential breakage with network intermediaries. There's additional buffering or delay requirements, but are not easy to handle well as well in browsers. So when I started looking at it, I started to think what really is the threat model for that? What is it protecting us? And if the same kind of protection can be done in other ways, basically. So yeah, I see people on the queue, so let's get the answer.
Yeah, Richard.
Just some quick feedback. Is this, if the concern here is purely denial of service, then I think I'm not real concerned. If it's about confidentiality or authenticity, then I think, yeah, we would consider the SFU part of the threat model. That's kind of the point of doing this. But if we're just worried about the SFU dropping packets, maybe we'd be worried about revealing more information to them, but I don't think that seems pretty secondary in any case.
Imad.
Yeah, so I guess the threat model was mainly malicious user impersonation, like someone in the call impersonates another person in the call. And I actually had the exact same slide in my presentation asking the working group about the signature scheme, should we sign or should not sign, because in the current spec right now, it's basically hand wavy, it's very complex, and we don't have an ideal solution for it. So I was going basically to suggest, should malicious user be part of the threat model, or should we drop it completely for now to make things simpler?
Yep.
Okay.
I think we should drop this. I mean, it's technically very hard to do with any reasonable performance, absent like. So I think there's like the, it depends on your model of the application. But if your model of the application is like the dumb version where there's basically like, like a single monolithic conferencing system, like the one we're on here, for instance, then signatures don't actually help because what it shows you about who's speaking is like entirely controlled by SFU anyway, at least for RTC. So so I think like until we have like a sort of much more like isolated streams and identity and that kind of thing, I don't think that this is going to like work very well. And so I think like we should punt this until we're like further along with the rest of crypto.
Sergio.
Yeah, I don't think that we should drop it. I mean, I think it's something interesting feature. I don't know how complex. Well, I know that it is complex to implement. I don't know if it is robust enough, but I don't think that we should just say that we will not have to implement it. I think it's a very nice feature, and it is something that from the application level, I would like to have it when implemented as phrase. I mean, to be able to authenticate what user is speaking in each track is something that for me as an application developer is something but it is very interesting. I understand that it is complex to implement. We don't trust the JavaScript application because it is hard for browsers to be able to display that information, but if the application is strategy is something that it's at least from my side, I think it's interesting. The thing is that we feel that it is complex or it is not robust enough. But just dropping just at the start, I don't think that it is a good thing.
Okay, I think I've got echo again.
Sorry.
Point isn't that it's hard to implement and therefore you shouldn't do it. My point is that there's that if this is done in a browser, there's like almost no meaningful threat model on which this adds any security, because you already know who's talking to you because you've authenticated them at the detailed SSRTP level, and the people responsible for displaying the UI that he's talking are is the website itself. And so the website can lie or not lie, but if it can lie, then signatures don't help. But if it can't lie, then who cares? So that's the point I was trying to make there. The complexity again, the complexity isn't implementation. The complexity is the crypto to make this work in a like meaningful way that doesn't like involve like an enormous amount of crypto or worrying about a lot of packet drops. As I think I'm not sure if I observed this on the list or somewhere else, but the existing design actually is broken in some respects.
Okay, we're going to shortcut this conversation because we have other topics, but this is good. Imad?
Yeah, I want to just echo what Iker said. It's not only about complexity, it's the current what's in the specs is not complete, it's broken. So my suggestion for removing until we have a complete solution. I'm fine getting back once we have a full working solution, but as of today, it's broken.
Right, Tim.
Yeah, I think we're suffering from not having heard the use cases. I think this discussion is really hard to do without knowing exactly what the use cases are supposed to be.
Point. And Sergio.
I also remember that there are other use cases that are not browser-based. I mean, this can be implemented in native applications, and we have clients that are already implementing this, and this is a feature that it is required for them. I mean, again, I don't, I'm not going to start to go into the details, but for a feature perspective, it's something that is interesting, and from that, I think it is really important.
Right. Richard.
Yeah, I think my biases are broadly in the same direction as Echo and Emad. But like Tim said, I think this is an area where I think we understand the implications for conferencing, but there are other use cases to have in mind here, and so I'd like to understand those use cases as well.
Okay, so what I'm hearing here is that there's some question mark over this one, but let's get back to this when we start talking about the Sframe draft itself. Ewan, do you have much left?
Just one question. The last slide is
okay.
Sframe. So WebRTC is surely about audio and video, but it's also about data channel, and there's also like WebSocket, Web Transport. Data channel can be used to transmit real-time data. It can be subtitles, anything really. So my question is Sframe, are there any use cases where Sframe could be used with data channel? Should it be in scope of either this group or the work that would be done in WFC? So yeah, that's the question.
Tim.
Yeah, I think fairly obviously the answer to that from my perspective is yes. I think there's some very interesting things you could do with having encryption, an extra encryption layer on the data channel over kind of multiplayer games and things like that.
Echo?
I guess the answer is I don't know. I mean, I agree with Tim that having multiple levels of encryption, things stuff like video games is interesting, but it seems like all the data is like being sourced by JavaScript, and so like why not just do that crypto in JavaScript before you shove it down the data channel? So I think I have to understand like what the threat model was and what you're trying to accomplish before I knew whether that was a good idea or not. I agree with the text here that there's no in principle reason why it couldn't be just data channel. I'm just trying to figure out what it does.
Justin.
I agree with Eric. It seems like there could be a lot of interesting things here. Like, there's plenty of applications that are offering end-to-end encryption in the browser for text messaging and similar things. And it at least would benefit from having like some sort of place where the actual cryptography is being done inside a secure environment. But I don't know how you solve the sort of issue of like the actual input still back in the untrusted domain. It seems like if you've at least solved the crypto part of it, then you're at least halfway closer to that final solution. And it seems like given the amount of usage that people have of communicating over just text, like there would be a lot of value if we were actually come up with some form of solution here. So I think probably in terms of like our use cases, that'll be pretty far down the list because it's a lot more complexity we have to take on. But I hope once we knock off some of the earlier things, then maybe some other folks could then take this on in terms of achieving that particular goal.
Yep. As Jonathan suggested, I'm cutting the queue here. Jonathan.
I mean, I kind of feel like, do you use it with data channel is the wrong level of question. I mean, it's, do you want to apply it to things other than audio and video is one question. And, then the answer is maybe, I don't know. But, whether you would set that up for data channel or WebSocket or Web Transport, carrier pigeons is sort of a separate, not that interesting question. I mean, I think that there's for the audio and video cases, there's also interesting things like, maybe you want to do Sframe over HLS. That sounds like it might be an interesting thing to do in some use cases, but I think that what you're transporting it over is kind of not the right level of question.
Mike?
I think the same problems that we have with audio and video would be much, much worse with data channels, because just like the packetization issue raised earlier, the SFU is doing a function, and for it to do that function, it needs to see some part of these frames. And so the data channels, if you're just taking it as like an opaque thing that you're trying to forward around, then you still need some sort of information to the SFU about each of these data channel messages. So the problems with packetization audio and video would be even more difficult with data channels, because they can't just be treated as opaque blobs. Otherwise, what is the SFU really doing with them?
Okay, thanks, John. I think that's the presentation. Emad, you're up next, and we're talking E2E.
I guess I'm not going to use most of the slides because Chair's already covered overview, remind everyone of the protocol. I might jump directly into slide number 5 in the wire format. Yeah, so I want to remind everyone with the wire format because I heard a lot of confusion about key IDs. So this is basically the wire format of an encrypted frame. It's a frame which has encryption header, it has the frame counter, its key ID, and at the end the authentication tag. So one thing to emphasize here is the key ID is per user key ID. It's not a global for all users key ID. So every user will have key 1, key 2, key 3, etc., etc. So because I saw from other slides that's about key ID conflicts. Hopefully this point is clear. And we can jump directly into slide number 8, open issues. Next slide. So the first one I want to talk about is dependency changes in WebRTC, other WebRTC working groups, what they need to define for SFrames. So there are main things here is, as everyone mentioned, signaling SFrame, like other SDB or other out-of-band mechanism where we use SFrame. Then we need to define a new payload type for encrypted frames. And the last thing is we need a generic RTB header extension that holds the metadata in plain text so SFU can continue to work. This needs to, for example, to need the beginning of the frame, the end of the frame, all other frame metadata like resolution, volume level, etc., etc. So we should be working with other working groups to get these things done. Next slide. Okay, back to what you said about signatures. So to be clear, I'm saying what's in the current document is not complete. As an example, it doesn't define how often the signature frame should be sent. What happens if the signature packet itself is lost? Does it have a repair mechanism or not? What if the recipient doesn't receive a signature packet? Should it request or should it drop? So this is why I'm saying what's in the current draft is not complete. I'm suggesting drop it until we have a complete solution. But yeah, so this is basically the question that you want to mention. I want to make sure we continue the conversation here if there is argument to keep it or remove it. Anyone have preference?
That was a question. You can jump in queue. There you are. And we don't seem to be getting audio.
Why don't I try, and then if Yuan comes back, he can jump. He can back in. So yeah, as I said before, I think we should pull this out for now. I think if someone comes back with like a clear use case and a fully baked solution, then we should reconsider. But like, I think having something that is kind of messed up in this spec isn't good. So let's take it out for now.
Thank you, Sergio.
Yeah, I think that, well, maybe it's a bit different. That I think that signature is nice, and we should not remove it, even if it is something that it is not strong. I mean, obviously, I'm not a crypto guy, so I'm biased. But I think that being able to identify who is who each strat belongs to is an important feature. And regarding the proposal to have what to have, I prefer to have something that it is not or not completely defined, that not having anything at all.
So
Okay,
Sergio,
so-
sorry, I want to make sure Sergio understands Sergio correct. So Sergio, are you with or against?
I would like to have it in.
As it is, or after revised?
I would prefer not to remove it, because removing something is much harder to get something back in that try to improve something that it is already in. I mean, because I am afraid that if we remove it, we never get it back, because it will never be completed.
That's fine. Okay.
So to be fair, Sergio, if it's not good, then it's not in by the end, right?
I don't know by the end, but at the beginning, removing it at the beginning, I mean, we will discuss at the end what happens at the end, but removing it at the beginning, I don't think it is something that is.
All right. So.
Okay, next slide.
No. We've got a long queue here. So.
Oh, FQ. Sorry. Okay.
So just to provide a little bit of feedback, Philip, Hanke, and I worked on an implementation which does pretty much the first bullet point there. We sent the signatures of the previous end frames, and then signed that. It's complex, makes the whole thing hard to maintain, and so far what we've seen is that the threat model is complex to understand. You're already in a conference with people that have changed keys with, so the fact that someone uses someone else's key, what does that mean? It's not very clear to us what value it adds. What it does add is a lot of overhead. So I am, at least for the time being, for removing it until something which has a clear path for its existence to be, devised.
Thank you, Mo.
I can see the motivation. It'd be a nice benefit to the users, but I don't see a practical way to do this that has any sort of assurance to a user. This essentially means that you'd have to have perfectly reliable delivery of everything, which makes robustness incredibly hard to achieve. And then if things weren't fully reliable, then how do you deal with the very high frequency failure of this? How do you expose that to the user? Is it a flickering, a flickering button constantly? It seems like this is fraught with user interface problems for it to be meaningful.
Thanks, Mo. Ewan.
Can you hear me? Yeah, good. Yeah, I would like to drop it. I think that at this point, until we have clear use cases and a clear path to fix it, then it should be removed. If we keep it, I fear that it will not be implemented. It will stay as is and untested, and will not bring value, and will just slow down the progress we can make.
Okay, Tim.
So I kind of don't want to keep it. I think looks messy, but we then lose one other attribute of signing of auth, which is that you're filtering out like bad packets. It's a way of, in my implementation at least, it's a way of deciding not to deal with something that's bad, and it protects the other layers. So you're losing that protection by dropping this.
Don't you get the authentication tag?
At what layer is that?
You multiple layers. You've got DTLS and you've got Sframe.
Yes, but if the JavaScript at the far end can, basically what you're allowing is the JavaScript at the far end to fuzz you.
Okay.
I think.
And Mohit,
Hi, do you hear me?
I do.
I see there's a lot of people who want to get rid of it, and maybe that's fine. I was just wondering that at least in the previous presentation, there was mention of using keys derived from MLS. And I was wondering if the keys are derived from MLS, would there be a use case where you still want who in the group is sending these messages? Sorry if this question is stupid, but I'm following this working group from the sidelines, and I'm not sure if how these signatures relate then to the MLS keys.
I can answer that
I'm
real
going to let
briefly.
Richard answer that one. Yeah.
Yeah, just real briefly, the symmetric crypto, that is just, if we don't have a signature feature, then the symmetric crypto, even if you get the keys from MLS, because it's symmetric crypto, any receiver can generate a stream for any sender, and so they can be freely exchanged and spoofed. You don't get any per sender authentication. So you still need signatures if you want per sender authentication, even if you're using MLS. Now, the one advantage of MLS, of course, is that MLS meeting participants have signature keys already, so it provides you the signature keys you need, but you would still need a way to put them in the Sframe protocol.
Yep. And last comment on this topic, Sol?
I was a bit confused by what Tim said, but I think now you're clarified. So I don't think removing this opens you for fuzzing, because you do verify the AES signature tags. In the end, what you don't know if somebody is using somebody else's symmetric key for encrypting. But I think you have other ways to know this, at least today, on the signaling layer.
I'm going to give Sergio one last shot at this one.
No, I agree with Tim. I mean, this allows fuzzing for the client side. I mean, I can inject whatever in the insertable stream. That has low, so the GPU will not drop it because it does not know by design what is in there. So from my client, I can send whatever content to any other client and try to fuse the for example, in this case, the video decoder or whatever. So, and there is no way that you can protect it.
So what I'm hearing here is that there's maybe one, maybe two people who like to keep this. I think what we're going to do here is take this to the list and confirm that this, but it seems at this point that there's not a lot of enthusiasm for keeping it. One thing we can potentially do is encourage those people who care about this to write a draft and plot out a design that doesn't have the shortcomings that have been identified with the existing one. So let's take this to the list. And Imad, do you have more issues?
Yeah, one last quick slide. So partial frames, because the current draft started as only focusing on frames, hence the name Sframe. But as the charter mentioned, we want to support like other decodable units like NALU. Naturally, it should be supported by default because Sframe, all the packetization happens after Sframe. And Sframe, we're going to encrypt whatever is passed to it. So it's either a full frame, it's half frame. So it should naturally work. I guess the issue here is just we need to mention it in the draft that it should support to work with other smaller decodable unit. And we're going to add support for this in the text. But the packetization and the encryption happen before reaching a stream. As an example, insertable stream in this case needs to pass the NAL unit rather than the frame itself. And with that, I think, okay, anyone?
Okay, Richard has a comment.
Just a quick question for you, Matt. I was wondering whether you think that this, I totally agree that this is something we should do because we need to be able to operate on subframe units. what I was wondering is whether you think that the S-frame framing needs to have any provisions to support this. For example, you might want something like a length field to delineate chunks of S-frame encoded data if you're going to get a whole frame and need to break it up into encoded units.
I need to think about, but I think the first answer top of my head, no, because all these things should be in the, for robots, it will be in the frame header extension, all this metadata. I guess the thing is, what about frame counter? What frame counter represents in this case? Just a null unit counter? Would it just work? I think it's something we need to think about it.
This is something that I remember seeing in Sergio's slides, so maybe we can
okay,
come back to that in a minute or two.
Okay, I think I'm done. Yep.
Thank you very much. And we're doing pretty well on time. We might be able to get Dr. Alex some time on the agenda after all. Let's go to Sergio now with the video codec stuff. All right, you tell me when you want the next slide.
Yeah, next slide. Let's go ahead. And what I was trying to explain in this set of slides is how the current the current codecs are used within Sframe or could be used with Sframe. What can we learn from that when we apply this to the or we try to implement the generated video packetization? So first, I would like to try to address how the current video packetization formats can be used within Sframe and how we are working with them in the current with the insertable streams to make Sframe work within the browsers. So BP8 is kind of I mean, this does not work out of the box because when you encrypt the full frame, there is some part that it is in the encrypted part that it is required by this view to work. So so when you encrypt the whole frame with Sframe, some part of the video of the payload is encrypted because it is what comes in the video frames, but the packetization adds some data in the beginning that it is sending clear. And the SVU use some of this content that it is sent in the clear section, so it can work on it, but it requires also some parts of the information that it is required. It's sent in the encrypted part, that it is mainly the iframe market, and also, for example, Chrome requires when that you do temporal scalability, that the picture ID that it is also sent in the encrypted part is rewritten. So in order to overcome this is typically what it is done is that when you apply this frame transformation, you just skip the first byte, the first byte that belongs to the BP8 payload headers. So by doing that, all the rest of the frame is encrypted, and this SVU can work and by checking what is the layer that this packet belongs to, performs temporal scalability, and check whether an iframe is received. So next slide, please. BP9 is different because all the information required by the SVU is sent in the payload descriptor that it is sending clear. So like BP8, the SVU can work with the complete frame encrypted without any issue. So this works out of the box, and you can just use Sframe with BP9 without having any kind of extra things in the packetization. The only thing is that when you use special scalability, as the SVU can drop any of these of the special layer that it is sent, that it is present in the frame, you need to pass each of the layer frames individually to the Sframe. So you have one video frame that has 3 spatial layers. You will have to pass each of these 3 layers to Sframe independently. At the end, they will be aggregated in the RTP payload, but the Sframe will be able to work with it without any kind of issues. So next slide. This is the when we're to the interesting part. I mean, H.264 the packetization does not send the whole frame, but it just replaces some part of it, especially the null unit header, null unit headers, and we replace the content with something that it is very similar, but it is not the same. So if you encode the H.264 frame with a Sframe, and you then apply the RTP packetization, some of the encrypted part will be replaced, and with the RTP packetization header types that it is sending clear. So when you receive it and you unpacketize it, you will have some missing information because then the stuff that will replace it from the encrypted to the non-encrypted part, you will not be able to have access to it. So the only way to solve that is that Sframe must work with null units. So it will encrypt the null data and just use the null headers as they are. But this obviously increases the overhead of the encryption, because in one frame you will have several null units, especially if you are sending SPS and PPS and say information. You will have much more overhead than one it will typically have in BP9 or BP8.
I see Justin in the queue here. Do you have a question?
A little bit of avoiding the overhead. One approach that I think could work would be that you sort of insist on, STAP type aggregation, and then like the SPS, PPS, are then sort of clear text as they are in like the VP8 or VP9 payload header. And so you end up then in the situation where you have like some of the stuff at the beginning of the packet is clear text, and then the actual payload that contains the the IRP frames, then becomes encrypted, similar to the VP8 or VP9, actual encrypted payload. And once you apply that sort of transformation of assuming that a STAP type aggregation is required, then you can think about it in the same sort of way as like a VP8 or VP9 situation, which I think is an interesting simplification.
Yeah, I was checking out this in aggregation units, and I'm not completely sure if it will work. It's something that I have think of doing, but anyway, you will have extra overhead that it is not present in BP9, even if it is smaller.
Sure. I think there's still some extra overhead, but you're not quite at the same sort of situation of having every single NALU of including SPS, PPS, et cetera, having to have their own Sframe encryption and resultant overhead. I think that problem can be solved.
Yeah, I mean, yeah.
Okay, Stefan.
Generally like Justin's idea. However, there is one additional thing to consider, and that is I think many H.264 based H.264 using SFUs also look into the slice header, which would be the encrypted part right now. So if I were designing this now, really speaking off the top of my head, probably what you want to do is to send something like just doing here the single null unit packetization thing, like sending the first 4 octets of the null unit in the clear. that would give you access to the slice header and some random macro block data which no one can use. And that would be compatible with how H.264 SFUs work, with my understanding. So some flexibility there is, I think, warranted. Thank you.
We now have Jonathan Lennox.
Hello. Yeah, so I think it's a little unclear to me just how much. So is the goal here that we should be able to do this with the SFUs being completely oblivious to the fact that we're doing Sframe, or is the goal here, or not? Because if not, then obviously we have a lot more flexibility in how we might want to rearrange these packets. I'm also a little concerned with how much standardization work is going to be to define exactly what is and isn't encrypted on each packet, because I feel like that's something that needs a lot of deep knowledge of each codec to know what precise bits are or aren't privacy sensitive, which seems like not something where there's a lot, where the expertise is necessarily even in the people who write the payload, the payload formats, because it's, I have a blob that the codec gives me and I send it on the wire, doesn't mean I know what bit does what exactly. So it makes me a little nervous how much work this is going to be and how much expertise it's going to need.
But I don't have any goal when putting this. I mean, what I'm just trying to describe is what we are currently doing to make Sframe work with the current payloads.
Okay. Yeah,
I don't want to. I obviously don't want to do this, and I would prefer to have something that it is agnostic, but just try to justify why do we need that's something that it is more generic, and try to avoid to have to do this for H.264, H.265, or whatever new codec that it is arriving. But just
okay. If this is just descriptive and not
yeah, it is just
advocative, that's okay. That's fine. That's fine.
Magnus, you're up.
Magnus here. I mean, I think this is a great example why you're going to have to go to this more generic, decide on what information is acceptable to expose for that is kind of agnostic codecs for SFUs to deal with, and then basically have each codec saying, yeah, this is what this IDU that the chat has been talking, say what is the smallest independently decodable units that the codec can handle, what type of sub level, like which nulls can you combine into what's to put in one S-frame, etc., and then packetize the S-frames inside that payload and have that generic information and the S-frame being fragmented across multiple payloads to fit whatever. So I think you're ending up in that design space if you're going to really solve this in a nice way, which actually minimizes SFU impact. Is that yes, you do one SFU style and then you deal with this. Okay, what's the generic information we need to deal with for the switching operations, etc. And you can also do then a proper security review of those particular fields and not have to deal. And at some future point that might change with new codecs, etc., new substructures, but at that point, bite the bullet then.
Okay. Oh, I was just about to say we're going to move on, but Mo.
Just to answer Magnus's point, we try to do that with frameworking, as he well knows, and it sounds simple at the beginning, but as new payload formats evolve, it's difficult to capture all of their useful semantics that would be necessary in a middle box for it to do its function right. So the concept of having a generic descriptor for all of these payload types, while very attractive, I think in practice we've seen that it's pretty hard to actually pull off and have any kind of lifetime in the market.
Yeah, but I mean, that's the same as switching of individual payload formats, and anyway, it's the same. You have to deploy them, and if it's not, if you have some generic parts and certain codec specific, you still have the deployment aspects of saying dealing with that. But I think you need anyway. You can't, if you're going to, you end up in a route. Something you need to decide for each payload format is to what to expose to be able to do the switching operation, and that needs a security analysis to not leak information that's sensitive, and so you're not getting away from that aspect. I think it's something you're going to have to deal with even with S-frames, or you have to treat them completely generic and put the logic somewhere else and have that step completely separate and say this is magic number 5, and then you have the logic telling the test if you 5 you should do it this way, just enumerating profiles or something like that. I don't know. That's
Okay, so it sounds like there's a bit more work to do here. Sergio, do you want to continue?
Yeah, please.
Next slide.
Yep. Then I like to also speak about AB1, because AB1 has one interesting feature, is that the packetization is designed to work with end-to-end encryption. So in this case, everything works out of the box. All the frame is encrypted by the Sframe. This equally to BP9, as the SVU can drop any special layer. Each of the in AB1 that is called frame, the spatial frames within the same RTP frame has to be encoded differently or independently, so they can be dropped by the SVU. All the metadata is included in a new header extension that it is called the dependency in the descriptor. I can go into much more details about how the dependency descriptor works, but I'm not sure if it is in the scope of this working group. But I can provide more details about how the dependency descriptor works, how what are the properties of the dependency descriptor. So, but regarding the SVU does not need to check any part of the RTP payload at all. In fact, it is a requirement in the AB1 spec that the SVUs must not inspect the payload at all and only work based on the information from the header, the descriptor. One thing is that the dependency descriptor, the header station, can be authenticated end-to-end, because it includes the one thing that it is called the active that called target mask, that it indicates which layer are being forwarded by the SVU in order to be able to do layer switching fast. So this can be changed by the SVU. So this is why the dependency descriptor can be authenticated end-to-end. Also, I don't think that it is encrypted. Authenticating this metadata is something that it is should be done. The dependency descriptor can be encrypted by hop, either by standard FEC 6904 or by the new spec by Cryptex. The dependency descriptor is codec agnostic. I mean, it can be applied to any codec, SBC or not. I mean, it supports temporal scalability, spatial scalability, and also what it is called the S-frame, the S mode. That meaning that to have a spatial scalability, but well, it's simulcast but multiplexed within the same SSRC. And also, it can be used to provide a raw packetization, because it includes markers for the start and the first and last packet within the current spatial frame. So it can be reused for packetization, and also can be used by other non-RTP protocols like QUIC, because you can just prepend this dependency descriptor to the payload, and you will be able to do a packetization in other protocols that are not RTP based. So next slide. is kind of my conclusion, but just try to trigger some discussion, is that not all video codec supports Sframe easily. I mean, especially in H.264, you will have to define it carefully and check all the properties that requires to modify the current packetizations in order to work with Sframe. And most worrying is that we will have to do this effort for each codec that has a specific RTP packetization by past and future. So it will be a never-ending process when new video frames come, the new video codecs are available. And it will create, a part of making the specification work much harder, it will also have create huge interoperability problems, because you will have not only test Sframe implementation between different browsers, but you will have to test each of the codec between these browsers. And one thing that it is important is to be able to know what SVU data required and what metadata from each video does the SVU requires to have access to in order to create this new video generic video codec RTP packetization. And also, I think one experience that we have learned, at least from implementing BP8, BP9, and AB1, is that it is better to have this metadata in a header extension than inside the payload. And if possible, I would like to have a solution that it is protocol agnostic, the same as we have with Sframe, that it is meant to be protocol agnostic. If we can have some solution that implement this packetization and this metadata required for the SVU in something that can be reused in other protocols that are not RTP based, I think that it will be nice to have.
Okay, are there any further comments on this one? Questions? Well, thanks, Sergio, for covering that. The next topic on our agenda is talking about the key establishment stuff. For that, we will have Richard Barnes. Richard, do you have someone to cover for you for taking notes, or?
I'll do that.
Thanks, Bubba.
Thanks, Bubba.
So, Martin, you're going to drive my slides here.
I just need to bring them up. I'm sorry.
No problems.
There we go.
All right, and already I have screwed up the draft name here because it's actually Sframe MLS. I got distracted by DTL SSRTP, which puts the key exchange first, but we're doing this in the Sframe working group instead of the MLS working group, so the Sframe comes first in the draft name. I put the asterisk there when I first sent Martin the slides because I hadn't submitted the draft yet, but there is now an internet draft that was submitted yesterday. So the idea here is, if we can go to the next slide, funny that we've just spent a little while discussing the hard parts around how we choose the units we encode. From the crypto nerd's perspective, the hard part is always the key management and not the choice of what you encrypt. So usual funny disconnect between the media folks and the crypto folks here. Right, so the Sframe, framing structure defines how you encrypt a media payload given a key, and the identifiers for it and the counters, etc. What it doesn't define is how you get the keys that you use for the media payload, and the security properties you get from the encryption obviously depend on the security properties of how you got those keys. The usual approaches we have to establishing the keys for things like SRTP are things like SDES or DTL SSRTP, which are really focused on one-to-one cases. And as you heard in the use cases discussions earlier, a lot of the cases for what we're looking at for Sframe are many-to-many, especially these conferencing cases. And so the desire here is to have a key management system that can address this group use case and get you good security properties for the keys you input to Sframe. Next slide, please. So just to provide a bit of background on MLS, it is another working group over in the security area where we've been developing this messaging layer security protocol. Originally, the kind of driving use case was secure messaging. So apps like Wire or WhatsApp that provide secure group messaging. And the desire there was to provide keys for those messaging systems that had the security properties you expect. So you have authentication of the party, you have a key that's only known to authenticated parties, that you can have more than 2 parties there, you can have a group instead of just a one-to-one connection. And the kind of more interesting properties here, sorry, I've tailed off at the end of the slide here. The continuity property here is interesting because with these messaging groups, as with conferencing participants, people can join and leave the group over time. So MLS provides a way to refresh the keys as the membership of the group changes, so that if someone can't decrypt media from before they join or after they've been removed from the group. It also provides forward security and post-compromise security, so that you kind of align the compromise properties with kind of what you expect. Next slide, please. Just to kind of give a feel for how MLS works as a protocol. When someone joins, they send a key package to someone who's already in the group that describes their capabilities. The joiner gets back a welcome message that gives them the crypto material for the group, and then the person who's in the group who's adding the new person sends a message, broadcasts a message to the group with an add message and a commit message that everyone else in the group uses to update their state to a new key that the joiner also has. Then when you kick someone out of the group, you just send a remove message and a commit message that updates the whole group so that the group's keys are no longer accessible to the person that was kicked out. That's just kind of giving folks a flavor for what MLS looks like as a protocol. It doesn't really have much relevance to Sframe directly. Next slide, please. The protocol question for MLS plus Sframe is how we take the outputs from MLS and map them to the inputs that Sframe needs. So if you think about what an Sframe implementation is going to need, it's going to need, when it's encrypting, it's going to need a way to figure out what key ID goes in the Sframe header. When it's decrypting, it's going to need a way to look up keys based on the key IDs that it's getting in the Sframe headers. So that's the Sframe inputs. In terms of what MLS produces, I mentioned that it rekeys every time you do a join or a leave. It can do batching of those, but that's sort of secondary. But in any case, it has this notion of epochs, which are these intervals at which the keys are rotated. And for avoidance of conflicts, for avoidance of nonce reuse, we need to produce separate keys per sender in the group. So the scheme here takes kind of this epoch and sender ID and packs them into the key ID, and defines a way for deriving these sender keys from the crypto data that MLS produces for an epoch. Just to kind of tell this story in pictures, next slide, please. MLS, like I said, produces this sequence of epochs, a linear sequence of things for the group. Each batch of joins and leaves produces a new epoch. And what's in the draft right now is at each epoch, we export an Sframe epoch secret from the group's secrets. And then we use that to derive the base keys that go into Sframe by KDFing that epoch secret together with a notion of the sender's index in the group. And I'll say as well, since we're MLS, another thing I didn't mention about MLS is that every member of the MLS group has a specific index in the group. So a side effect of MLS is that if you're in the group, then you know a unique uint32 for yourself that defines, that uniquely identifies you within the group. And so we can use that to branch off sender keys from the group secret. So the Yeah, so the idea here of the draft is to take the key ID in Sframe and use that to locate where you are in this key schedule, and so you can identify the sender base key that you're going to use for encrypting and decrypting. Next slide. Now, these epochs in MLS are identified by an 8-byte counter, which is big for a parsimonious protocol like Sframe. So for compactness, the draft says you can truncate this epoch to a number of bits we call E, which basically defines your reordering window, defines how many epochs you can have in play at a given time as you're potentially rotating keys with some frequency. My guess is that like having 4 bits or 8 bits is probably going to work in most cases, depending on the dynamics of key rotation. This is a parameter that much like the group is going to have to agree on. The participants in an Sframe encrypted session are going to have to agree on what encryption algorithms they're using, and that they're going to have to agree they're using this scheme at all. They're going to have to agree on this number of epoch bits as another parameter to agree on. But then the key ID encoding scheme is pretty simple. You stuff the epoch in the low order E bits, and then the remaining bits are the sender index. So the key ID, it's just a packed truncated epoch, and the sender index grows as the number of senders increases, the size of the group increases. Next slide, please. So yeah, this is really the draft. This is really the meat of the draft. So the mapping between the key ID and the epoch and sender, which gets you the key schedule, and then the way you derive the per sender keys from the key schedule. Next slide. So I've implemented this scheme in an Sframe draft implementation that we've got going on GitHub. No magic here. And so that brings us to the last slide, which is propose adopting this draft alongside whatever draft we adopt for the base Sframe here. There's a couple of questions I didn't mention here. We could use the analogy here to DTLS SRTP, or DTLS in that compound. DTLS is used to negotiate the parameters for SRTP. In particular, negotiates the cipher suite that you're going to use with SRTP. We could do the same thing here by defining an MLS extension to negotiate parameters like the cipher suite or the size of the epoch. That's not in the draft right now, but it would be a natural extension. So I'm curious whether people think that would be useful. I think another thing that Raphael noted to me as we were preparing this is, and I forgot to put in the slide, is that MLS actually itself produces per sender keys for encrypting its own messages. And so it's got a scheme that is a bit complex compared to what's defined here, but provides more forward secrecy within an epoch. We could use that internal MLS secret generation scheme here. It would require a bit more intimate collaboration between MLS and Sframe as opposed to just exporting a single secret. But we could also do that. It would get you slightly better forward secrecy properties. So with that, I'm happy to discuss, take questions, comments.
It's Q time. Enad.
They're very excited, interested about this. I actually put myself in the queue before you brought up your last point about using per sender key. I'm actually against it. I prefer using the root read key for some reason, because MLS per sender key allows ratchet per message, and due to for RTC communication, we can't have ratcheting because some frames will be lost, and we can't run this. So I think the simplest thing to do is just rely on the root secret or root epoch. I guess the question I have for you is, I didn't get a slide about key ID derivation. Is this the Sframe key ID or another key ID?
Yeah, I think the only key ID I'm talked about here is the Sframe key ID.
But everything else is would be communicated out of band, like the epoch and everything else, right?
I guess I don't
Like
understand.
what information does it need to go in the Sframe payload? Only KID, right? We don't need anything else. Everything else should be in the out of band.
Yes, the Sframe header has a key ID and a counter, which I guess we didn't actually do an Sframe overview in this session. But the Sframe header has a key ID and a counter. So the proposal here is that the counter, the nonce formation works the same way as in Sframe in general.
Sure.
And then the key selection is just guided by this key ID as defined here.
So why not just be a sequence?
Matt, I would note that I think you and I have a disconnect here. This key ID, you mentioned in passing earlier that in your view, key IDs are per user. So each sender has a different key ID space. I think I might disagree with that assumption, just because of the way it requires some additional coupling between the Sframe layer and the application. So this scheme is designed so that the key ID space is shared across all of the senders, and when the Sframe stack gets a decryption to do, it doesn't know kind of which senders, which users stream it came from. And so that's why you need to encode the sender index in there. Otherwise, you could just encode the epoch.
Interesting. Okay.
Smells like an issue to me. I think we should probably resolve that at some point.
Yeah, yeah, we need to take this.
Okay, so Eric?
Really, I mean, this seems like good stuff. We could call out the details. I actually found myself a little lost in that colloquy you just had with Imad. Like, we agreed the packet has to carry some indicator of which like everyone has to use their own key space or non-space in some way, right? Otherwise, you have thermal problems. So you need separate keys, or you need a big ass non-space, something like that, right?
Yep. I think Imad's assumption is that something at a layer outside of Sframe can indicate who the sender is, and then the key ID can distinguish keys within the sender's sequence.
Correct.
That seems to say we definitely have to resolve one way or the other.
Yes.
Yes. Assuming I understand this issue about this issue Matt raises about the ratchet correctly, I agree. It doesn't see much value in trying to use the more closely related secrets. And I do think it'd be nice for MLS to negotiate the cipher suites. Seems like otherwise you're going to have like a pile of problems. And one thing I should mention is that you want that also because you want to know why you're getting, you want to have enough context to know why you're getting what you're getting when you support the keys.
Someone captured that in the notes, the cipher suite issue, and we'll go to Jonathan.
Hello. So I just wanted to, bring up a side conversation Martin and I were having in the chat, which is that, on the question of whether the epoch truncation needs to be flexible. I think he commented that he didn't think it did, and my response was that I think that if we were only talking about true interactive media, where you have the level of interactive conversation round trip time, I think I agree. But I think my comment was we probably need to make sure before we make that decision that we don't have any use cases where stored media would be useful. Where obviously if you have stored media, then you have a much larger history of epochs.
I actually think
I might jump in queue there.
Yeah, Martin, you want to go ahead?
Just in response to Jonathan, I suspect that in the case that you have stored media, you will still have a progression of epochs that you can recover from a low bit count epoch thing. And in particular for stored media, you probably won't have periods where you miss multiple epochs such that you lose synchronization. So it seems to me like you could probably get away with a very small number of bits even there.
Yeah, I was going to say a similar thing, which is that stored media is this case I don't worry about here. It's really the desynchronization problem that is the reason that you need a non-zero number of bits for the epoch. If everyone were in sync, if everyone were coordinated on the epoch out of band, you wouldn't even need to signal the epoch at all. It's really that some folks might be a couple of epochs behind that you need the signal and you need a few bits of it.
Yeah, I mean, I guess the model I'd have is somebody, leaves a voice message in the channel for people to listen to when they come back. Something like that.
Mm-hmm.
For some broad definition of that. Obviously, I'm being very, hand-wavy about what the user experience is, but.
Okay. That's good input nonetheless. Sergio.
One small reminder that when we talk about MLS integration, that we should be able to support any kind of key management system into Sframe. So just try to when we discuss about how MLS should be integrated into Sframe, just try to not to adapt too much Sframe to what is MLS requires, especially for example, or taking into account or the discussion if we will need to have a different standard index within Sframe or not. I mean, I will just try not to integrate too much both solution and just to assume that because MLS supports something, we can just skip that discussion for an Sframe.
Yeah, I think we have a pretty clean demarc here. In fact, in the code we wrote to this, there's literally a separate class, a separate inheritance boundary that separates the MLS-based keying stuff from the base Sframe stuff. So I think we're pretty good. If you think that there's unnecessarily entanglements here, please speak up. I'm happy to sort those out.
Yeah, no, I think that the question is if the key space is global or per sender, and if we need to carry a sender index also in Sframe or not. I think that this is my main concern, and I just will try to have this discussion in Sframe, and if MLS can be optimized, it would be much better. But I would like to have the discussion and to be like kind of KMS agnostic as well.
Yeah, no, that's a good point. I think that the idea that the key ID needs to provide distinct nonce spaces per sender is Sframe generic. And then each key management scheme needs to assure that property. They need to assure that however the keys are identified, that you end up with separate keys per sender.
Okay.
This is just a particular scheme for doing that.
Okay, Tim.
Coming back to the epoch question, can you tell if it's wrapped? Like what happens if you've got the wrong epoch?
If you've got the wrong epoch, things will fail. You'll have different keys, and so things will fail to decrypt.
No, well, except they'll decrypt, but you won't get what you think, which comes back to this authentication. Like if you're not running.
Because we're using authenticated encryption, if you try to decrypt with the wrong key, the decryption will actually fail.
Okay.
Modulo, my cryptographers in the back of my head screaming about non-committing AAD. There are cases, like exceptionally rare cases, where you can decrypt with an incorrect key and the decryption will succeed. But with overwhelming probability, the decryption will fail. And so you'll know. And so you can recover from epoch wraps with trial decryption.
But we try to avoid that.
Absolutely.
Okay, well, thanks, Richard. Do you have more on this one?
Nope.
Any other questions? So just been talking to Bobo offline, and we do have one volunteer for another presentation, but I'll put that on hold for a minute because it's about time that we start to consider whether or not we adopt some drafts. So I guess the first question that I'd like to get a sort of indication of, maybe I can start one of the show of hands things, is how many people have read the Sframe draft from EMAD. Okay. That's reasonably good. Give people a little bit more time to find the tab. I need differential privacy for this one. Okay. That's looking pretty good. All right, that's a good number. And how many people have read the MLS draft? I know that's very new, but
all of MLS or the MLS King draft?
Sorry, do you mean the one that he was presenting, or do you mean the MLS
yes,
draft?
that's this one that's been the one that has just been presented. The very short draft that Richard just talked about. All right, based on this, it's probably a little early to start the consensus call for this adopting of this particular draft, but we might want to talk about the adoption of the core Sframe draft, realizing, of course, that this is just a starting point. If anyone has any idea that they might want to propose some dramatically different approach, now's a good time to speak, because I'm going to ask people to raise their hands in favor or against, if you do not raise your hand, adoption of the draft Amara Sframe.
Martin, just a gentle, quick point of order. There is a request to relay the results for the audio recording. For the first question, have you read Sframe? Out of 44 participants, 16 raised their hand, 6 did not. For the second question, have you read the short Sframe MLS draft that was just presented? Out of 44 participants, 4 raised their hand, 18 did not. Thanks.
All right, thanks, Boa. So I'm going to start a show of hands now. Wow, we're voting again for adopting draft Amara Sframe. We'll have to get a better name for that when the time comes, because it's a little bit hard. But if you think we should adopt this draft, raise your hand. If you think we should not, do not raise your hand. If you're undecided, I suggest don't raise your hand. And Eka has something to say, which we can hear while people continue to vote.
Push the wrong button.
Certainly raised his hand there.
Just keep doing that instead of trying to vote. It's fine.
All right, there are 3 people who think we might not want to adopt this draft. Does any one of those people want to say why? I see. Eka, are you raising your hand because you want to talk? Okay. Colin.
Hi. So I'm assuming we will eventually adopt this. I said no because I want to better understand how it interworks with RTP and all the packetization, and get a handle on that first.
That sounds reasonable. Anyone else, Sergio? Okay. Well, given the time, does anyone feel that they need to see another presentation? I would have to take a few minutes to get it. Sergio, you have something to say?
Yeah.
Okay. So what I suggest we do here is we'll send around an email asking for confirmation, and if people want to make arguments for maybe delaying a little rather than accepting a 0-0 draft, then that is perfectly reasonable. We should discuss that. But the chairs will talk about that, and we'll see whether the list agrees with the vague indications that there's support for adopting this one. And I'm going to try to find Dr. Alex's slides, which is probably not going to work out very well for me. Oh, great. Dr. Alex, would you like to speak to this one?
Yes, I'd like to. Can you hear me okay?
You're a little quiet, so speak up.
Can you hear me better now?
Yes, indeed. Thank you.
All right, great. So this is not a status report, and I didn't write any code yet. See that more as an declaration of intent to work on a specific problem and a use case that I think Sframe could be applied to and provide good result that is slightly different than video conferencing. Next slide, please. So I took that from PERC, but I think it applies to the video conferencing in general in terms of trust model. The endpoint and the key distributor are trusted, but then everything else is actually not trusted. Right. Next slide. If you go into the streaming, here again, the end cases are trusted with the specific case of the web application where the JavaScript and the browser are respectively untrusted and trusted. The key management system is also trusted, but you also have quite a few other entities in the system that are also trusted. The ingest link is trusted until very recently. Everybody was pushing to YouTube Live, Twitch, all of that using straight RTMP. The media platform itself is trusted, and it actually needs raw access for all kind of transcoding and chunking and preparation of the content. Only the delivery is then encrypted, and the encryption is media transport protocol specific, so it does not apply to any kind of media. So that's the difference in trust model between what we have in the video conferencing and what the streaming people have. So next slide. In the specific case of web application, this is becoming even more complicated. So I'm not going to go into this slide, which is the full slide from the encrypted media extension for browsers. Next slide. I'm going to use a simplified one. So this is the simplified one, where you would have the browser or actually a native app as well. Think Apple TV or Android TV or Samsung TV, whatever your poison is. And you see here that already you have assumption about the fact that you have storage and that the delivery protocol will be either Dash or HLS. But globally, you have a secondary encryption with an external key management service. So usually people use PlayReady, Whitevine. There are quite a few, Fairplay. Depending on whose provider and who you're targeting, you have a different key management system, but the concept stays the same. Next slide. The problem is this: apart from the delivery itself, everything else almost needs to be trusted in that model. Next slide. So it raised the question, so even though some of the assumptions that were used when those streaming technology were developed have changed a little bit, for example, the ingest link is not trusted anymore, we see more people moving to RTMPS, is still required to have the capacity to transcode into the media server, which preclude the use of end-to-end encryption. Actually, there is an alternative to transcoding onto ABR, is to do that operation on the sender side by using simulcast or SVC, which a lot of the video conferencing or broadcasting real-time system use today, where all the media manipulation, encoding, and encryption is done sender side, and then your infrastructure is mainly made out of SFUs. So question number one, if I do not trust the platform and want to use my own keys, how can I do? Question two, if I would like to use the current DRM infrastructure, or at least the key management system there, with a different media transport and HLSMX dash, like WebRTC, would it be feasible at all? So I think with Sframe, given that we separate the media encryption itself from the key management and so on, there might be some opportunity to bridge the gap, right? And allow something that is a little bit smarter, especially for broadcasting infrastructure that deal with real-time content and not video on demand. I believe that video on demand is pretty well served with the technology there is today, but the boundary between video on demand and real-time, with people being stuck at home and wanting to participate interactively with media they watch, is blurring nowadays. And so I think that question becomes interesting. Next slide. So if you, that's the last slide. And again, on top, you can see that the only thing that is trusted is the ingest link, because you're using a transport layer encryption, and then the delivery at the end. And the key management system, the encryption is happening between the streaming endpoint and the player itself. With Sframe and end-to-end encryption, we could have the capacity. We could have the capacity to not have to trust the platform we're sending the media to, right? And there's quite a lot of demand there. So the question is, can we avoid to do that in a specific manner? And can we try to unify? It looks like there is opportunity to unify the top one and the bottom one. So we're going to spend some time investigating this, and if anybody is interested in the same question, that's an opening for anybody to come with us and join and participate in the investigation at this point. I see another interest for the Sframe group is that the scalability model and the trust model being different, we would have two different usage of Sframe, and we would be sure that Sframe is really agnostic to the use case, and that we got the right boundary around the media encryption, and we're not being biased by using any kind of key mechanism or key management mechanism on use case. Another problem, so next slide please. Another problem in specific to streaming is sometimes you can have a single source and 2 to 10 million of viewers. And so there are some limit to some of the key scheme and key rotation scheme that have not been designed, not only for the 1 to N. So we saw that Richard was speaking about 1-to-1 scheme and separately N to N. Now we're speaking about 1 to N, with N being very, very large. I'm not sure there is anything specific that has been done to make sure that we can generate that many key, or even if we need to. That's about it.
Okay. Any questions? Tim.
Yeah, I think this is interesting. I think there's the 1 to n. There's also a 1 to n where n is a relatively small number, and I think so. Kind of extending that somewhat, and I think there's one other thing which is potentially kind of stored-ish media. There's some interesting stuff in that space. But I think the key thing that we're missing here, and I haven't heard yet, is that actually it's not, in a lot of use cases, we're not actually worried about trust, we're interested in deniability. The service provider wants to be able to say that they haven't seen the pictures of your baby, or that they have no access to that, to your board discussion. And so it's about plausible deniability rather than actual trust per se.
No, that's a good point. I think there is interest for the platform also to be able to say, you know, even if the government asked me to give them access to your data, I wouldn't be able to, because I do not have access to the data. I mean, there are incentives for all the parties in the chain. So, team, would you be interested in working on the matter, or at least, you know, play along and have a skeptical, critical eye on whatever we're gonna come up with?
So I'm interested in following along. I think my use case is much smaller than yours. I'm like, where for me n is 10 typically, and I think the other differentiator, which probably doesn't make any difference, but the endpoint is probably a lot smaller. Like the ingestion endpoint is probably a lot smaller for me. But yeah, I'll play along.
Okay, what we see in practice is when n is less than 1,000, you're more or less in a glorified video conferencing mode. That's when n becomes bigger than 1,000 or 50,000 in some specific case for MLS. That you have some difficulties that do not have a practical solution today and that will require additional work. Anyway, thank you for your time.
James.
Am I audible?
No.
Thank you.
Always wanted to do
that. I'm interested in at least observing this work. I'm unclear of what the benefits are to doing encryption all the way back to the studio or the camera, particularly when we're talking about n equals millions, or where the kinds of content are effectively public domain, where it's the content of which doesn't require any confidentiality.
Content doesn't need to be secure and doesn't need to be confidential. The biggest example I have in mind is public debate or auction houses that have a lot of participants. This work doesn't apply, but there are still quite a few use cases where you would like to unify high latency and low latency encryption solution and advertisement. I didn't touch on it, but advertisement is also a case that is problematic in that context. And there are some other cases where, let's say, you're HBO and you want to do the equivalent of Game of Thrones, or the Super Bowl will be a better example because it's live content, right? And you do not want to trust any single platform. Actually, you want to have 2, 3, 4 of them for redundancy, but you still need to want to control the access yourself. And so basically that secondary key become the token. People buy the token to pay-per-view, if you want, and through that encryption system. And that puts the access and the encryption in the hand of the content generation and not the distribution platform anymore.
Okay, well, I'm going to suggest that we we wrap this up. Is there any other business that anyone would like to bring up in our last 5 minutes? Lauren.
I'm going to share this. I was going to share this in chat just now, but there's another. I don't know if this is necessarily in scope, but there's a project that is doing peer-to-peer video conferencing, and I wanted to, I guess, just at least make people aware of that use case working. It can swap between direct peering and using an SFU if just for scaling properties or as chosen by participants through configuration. Anyway, it just seems like something that could be related and should be something to know about.
Well, thank you all for attending and the good discussion. We will follow up on a couple of issues on the mailing list and continue the discussion on those drafts. Thank you very much, and good night, good morning, good evening, whatever it happens to be where you are.
Thanks, everybody.